Example 6, a water tank on a farm near Swift Current, Saskatchewan holds 6,000 liters. Graph A represents the tank being filled at a constant rate. Graph B represents the tank being emptied at a constant rate. So in graph A, you're filling a water tank. So this is the volume. It starts with 0, so you have no water in it. And as time goes on and these minutes increase, it goes up. Okay, it's a straight line, so it's linear. Let's compare this to graph B. Graph B, we're emptying the tank. So it starts with 6,000 liters. So that's why at time 0, your starting point, you have water in the tank, and it decreases down to 0 liters as you let the water out of the tank. So our independent variable, remember, is always along the horizontal axis. So the independent variable would be time. The dependent variable is always along the vertical axis, so it's volume. So that's kind of just a review for us. Determine the rate of change. Rate of change, remember, is going to be the change along the dependent variable. So we can say change along the y, we say delta y, over the change along the independent variable. So just a shorthand way of writing it is delta x. So we want to look at this change. So if we look at graph A, so when we look here, it started at, well, we can pick any point. I was going to say it started at 0 here, but let's make the numbers a little bit maybe easier to work with. Let's just pick a point right here. And if we take a look at this little slope triangle here, okay, so in 40 minutes, it filled to 2,000. So y first, so it's a difference of 2,000 along here. So we're going to say 2,000 liters. The units help us understand what it represents. This happened in 40 minutes. So 2,000 divided by 40 minutes, you would divide that and you're going to get 50 liters per minute. So those units are still there. So what does that mean? The liters per minute, this means that 50 liters is added to the tank each minute. Okay, let's look at graph B. So in graph B, if we take our little slope triangle here, okay, now it is actually decreased by 2,000. So the rate of change is decreased. So we're going to use negative 2,000. We're draining that water. It happens a little faster. It happens in this time period of 20 minutes. Okay, so it's negative 100 liters per minute. Okay, so what does, let's make some space there, this actually mean? This means that 100 liters of water is removed each minute. So we call this rate of change. How fast is it changing? It's changing by 50 liters every minute. It's increasing. In B, it's changing by 100 liters, but decreasing, so it's removed each minute.